Hey, Steve, I ran across a article on digital tools meet practical applications.
Nice.
And it's interesting because the quote from Tim Shimbara talks about what data-driven manufacturing does is provide the infrastructure to improve how business runs. And I think that's a key point. You know, when we talk about digital manufacturing in general, right? There's a focus on the data and the digital tool itself. And that's not what the value is. The value is doing something with that data. And I think, the article goes into a couple of really interesting use cases. The first one they have is machine monitoring and facility management. Collecting data right off the machine. Our friend Russ, helping out on Empty Connect and
how to get that data,
how to derive data, and it gets into interesting use cases related to that.
It gets into the endless possibilities.
Yep.
So I mean, machine monitoring or just pulling data from your facility wherever you can, as long as you know what data you want, but if you know what data you want, that's obviously key. But the beauty is if the data can be pulled, even if you don't want it, as long as you know you can pull said data,
right?
The possibilities of what you can do with that data are endless. They really are.
Yep. And the article also has a key element that I want to talk about too, because machine monitoring is not the solution itself, right? You're not buying the data collection as the end state. The end state is to say, hey, there's a problem here, right? You have all this information coming off the machine to say this thing's working great or it's not working great. We need to do something.
Yeah, let's say your technician says, hey, everything's going great. And then it comes back from inspection.
Right.
And inspection's like these parts are all scrap.
Yep.
It's like, well, my technician, my operator, told me everything was running great. Well, what can I tell you? These parts are junk.
They don't look so good.
What happened in between?
Right.
How do you track what's in between?
Exactly.
You need data.
Yep, absolutely. The next section the article talks about is cutting tool management. And you and I have been talking about screws in general in the past podcast, and the idea of solid inventory management is outrageously understated. We've been talking about screws because that's been affecting our life. But if you're in a manufacturer, cutting tools is your life, right? So having decent levels of inventory management and being able to see, have I used this insert before, or what is the potential life, or
can I afford to break this tool?
If I break it, do I have to wait a week to get a new tool, right?
Right.
So there's maintaining tooling inventories and accurate records of your cutting tool needs. So not only you can see history and things like that, you can start to see trends of what tools are working well. There's a lot of back to the machine monitoring, right? Mm-hmm. Being able to develop patterns and trends. The fact that you're monitoring your cutting tools, there's some value in that.
And I know earlier you talked about how cutting tool management is typically thought of as an outside of the machine data, but this part of the article also gets into cutting tool management with respect to tool wear.
That's true.
In the machine. And we've seen back at IMTS 2018 when I forget who the manufacturer was, but it had the offset could be adjusted on the fly of the tool with respect to the tool wear. Because if you notice or if you see any variation in your part dimensions as it's being cut, in variations that aren't supposed to be happening, it's an indication that the tool is wearing.
That's a really good example. I remember back at Eaton where we're cutting a new material for us. It's called L605.
Okay.
It's a nickel-based alloy, but it has I think a high level of cobalt in it.
Oh.
And it's very abrasion resistant. So it's used as sleeves or bearings. Okay. First time we're cutting straight cylinders, small pieces, 2-inch diameter stuff. And it was so hard on the tools that we had to build in a tool path that accounted for tool wear, because as we're cutting the one piece, we're fairly immature at that process. We're going through like 1 or 2 inserts per piece.
To the point where you're modifying the tool path, before you even start cutting.
Yep.
Now imagine if you just had like the perfect path, ideal. So most tool paths, I would imagine, are written in a perfect world.
Right.
Like there's no tool wear that's going to happen
no
during
deflection.
this cut.
Yep.
But as Eaton clearly found out, there was. But imagine if you had the perfect world program go into the machine And instead of having to change an actual person have to rewrite the tool path to account for wear, the machine does it itself.
Yep, absolutely.
It lets you know that the tool is wearing because the part is varying in this way, but the machine's like, hey, we're making this adjustment for you.
Yep. And the last section the article talks about is predictive maintenance.
Predictive maintenance.
Steve, this is your jams. Tell me about predictive maintenance.
Predictive maintenance is data-driven maintenance. Yep. So getting back to the digital tools,
yep.
why you would want to invest in digital tools. Predictive maintenance is ideal because you get to see what's going to go wrong before it goes wrong.
Right.
You get alerts, like you mentioned alerts before, whether it's, your stack light turns orange. Mm-hmm. The whole idea of predictive and also the next level prescriptive maintenance is you never see that stack light turn red.
Right.
You address something before something happens, and prescriptive is looking back actually at historic data, mm-hmm. not current data or recent data, but looking at historic data for patterns.
Yep.
And this was when the tool started to wear, or this was when the tool reached its end of life, not broke.
Right.
We're far from that. That's reactive maintenance.
Yeah.
Prescriptive and predictive maintenance looks at the data to see when something needs to be changed. Again, that even falls into, machine monitoring and cutting tool management, which is sick in some cases, not always cutting tool management because it's maintenance. But again, it's determining a maintenance schedule based off of the data from your machine in your specific use cases,
right?
Which is really forward thinking, as opposed to, let's go back to like preventative maintenance. Mm-hmm. Preventative maintenance isn't data driven. Right. It's from it's from field testing. Right. It's from the manufacturer's testing before they released it as a product of the machine. I can associate this more with automobiles than I can with cutting tools or machine tools. Do machine tools like in your experience working at Eaton, mm-hmm. when you guys acquired a new piece of manufacturing technology, did it come with a maintenance schedule?
Yeah, definitely.
So machine tools actually do come with maintenance schedules.
Yeah, I mean, if you consider all the fluids, all the electronics that have to be serviced, right? So they'll tell you, you got to clean your filters, and then change your hydraulics, service and calibrate your machine. So there's a service schedule.
So that is from the manufacturer, though. Usually, that's not from you, the end user.
No.
It's from the manufacturer telling the end user, hey, from our experiences, like developing this product, it needs to be maintained like this if you want it to continue working the way we designed it to, but you expect it to work.
Yeah.
So try to follow this.
Yeah, exactly.
And the customer, regardless, I don't want to get too deep into this, but the customer always has varying expectations from the manufacturer of a tool being used. And the beauty of predictive maintenance using data coming from, a mm-hmm. digital transformation or digital adoption onto your shop floor is that maintenance schedule isn't written by the manufacturer who has limited experience with the that sounds crazy and sounds really like aggressive, but the beauty is that means the maintenance schedule is determined by you,
right,
in your system.
Exactly. That's
instead of which is more reliable. Not to say that the manufacturer's not reliable, they are, but
it's individualized based on their needs. We know manufacturers going to buy the commodity style CNC mills, but they're going to use it differently every time. They're going to use different materials. They're going to have different coolants. They're going to use 1,000 different options that, it's specific to their needs. And that's where, the value of the data-driven maintenance adds. And, I think also the cost of reactive maintenance versus predictive maintenance is outrageous. Like if you actually did the numbers of lost downtime, lost revenue from a machine being
from preventative versus predictive,
reactive. Like if something breaks, right? So the debate is, if I have to fix it, why not just wait, use it till it breaks? Yeah, you're may get another cycle or two out of this thing, but now you're hurrying to get the machine back up running. Where if you have predictive maintenance, you can allow there's always gonna be downtime for a machine. No machine is ever 100% running.
Sure.
You can schedule a specific maintenance cycle nights, weekends. There's certain times where in between parts, right? So there's the ability to schedule when this thing will be down, as opposed to something is broken. Now I got to order something from some company somewhere. Hopefully I get it within a couple of days, as opposed to ordering ahead of time and having it sit and wait for you. So it's a different mind shift. And I definitely agree that it's a lot of value not having your machines broken.
Yeah. if you're working on the mindset of if it ain't broke, don't fix it. You're losing money.
You're losing money.
Even if it's not broke, you're losing money.